Good morning, everyone. Welcome to today's Winter Pulse meeting. I'm Corey Leeson. I'm one of the directors at Saskatchewan Pulse Growers, and I'm going to do my best to host the meeting today. We would like to be in Assiniboia with this particular meeting, and that was the plan, but it changed relatively recently. I know we were in Assiniboia for a meeting maybe 3 or 4 years ago or so, and it was fantastic. Great facility down there and great snacks at coffee break. I remember that. So it's a bit disappointing that we weren't able to run today's meeting in person, but that's the times we're in, and so we're trying to adapt as best we can, and hopefully you'll find today's webinar useful and informative as well. And it's a cold day, so I guess travel today isn't the worst thing to avoid. For those of you in attendance today, if you've provided a CCA or CCSC number when you registered, then you can get credits for today's presentations. And also for today, the proceedings are going to be recorded, and so there's going to be a link in an email coming from Saskatchewan Pulse Growers to access those recordings after today's meeting. There's going to be 2 question and answer periods this morning. So one after the first half of presenters, and a short break, and then the next set of presenters and another question period near the end of today's event. So if you have questions, what we're hoping to do is trying to direct people to the questions box in the GoToWebinar control panel. So give that a try and put your questions in there. There's also handouts and relevant resources for today's session that you can access right through GoToWebinar in your dashboard. And those resources will be included in the email you receive following today's event as well. On behalf of Saskatchewan Pulse Growers, I want to thank our sponsors for today. That is Bayer, Nexus Bioag, and Syngenta. I'm glad to have sponsors supporting Pulse Growers in the province and activities such as this. And we're also really glad that because we had to pivot to an online only event, we're glad that you kept your support with us, and that's greatly appreciated. Engaging growers is one of the important key result areas that Saskatchewan Pulse Growers has, and these winter meetings are a great way to do that. We've always had good attendance and try to situate meetings around the province to reach all pulse growers or give everyone a chance to attend. And because we moved to virtual with this and the next week meeting, we've sort of spread those presentations out over 2 days and consequently have a half-day presentation today. And then the other half will be on February 2nd. And so if you would want to register for that one as well, you can catch up on the remaining presentations then. Improved yield of established pulse crops like lentils and peas, as well as increasing smaller adoption crops or smaller acreage crops like chickpeas, faba beans, soybeans are important strategies for us and an important key result area for Saskatchewan Pulse Growers. And we're covering topics today that are related to both of these priorities. Continuing to diversify the use in markets for pulses through market development efforts, as well as expanded market access, are also key priorities for Saskatchewan Pulse Growers, and ones we work closely and rely a lot with our strategic partners in Pulse Canada. We look forward to hearing more on these important areas in today's presentations. So with that, we're going to start off today with the first presentation on-farm agronomic outlook for pulses, and that is going to be provided by Sarah Anderson, who is the Agronomy Manager at Saskatchewan Pulse Growers. Sarah joined SaskPulse relatively recently in 2021 after several years working with producers and agronomists in West Central Saskatchewan through independent crop production and ag retail providing services. Sarah obtained a master's degree in soil science through the University of Saskatchewan, and I guess her thesis subject was zinc fertilization in lentil in Saskatchewan to increase yield and grain zinc content. Sarah is actively involved in her family farm, a mixed livestock and grain operation near Scepter. So Sarah, if you want to take it from there.
I think I was on mute. Thanks so much, Corey. Pleasure to be with everyone today, at the very least virtually. As mentioned, I will be discussing the agronomic outlook for pulses. Just want to do a quick check-in and make sure that everyone can see my screen and hear me okay.
We sure can. You look great, Sarah.
Perfect. Full disclosure before I dive into this topic, I don't have a crystal ball. Certainly would make things a little bit more interesting if I did. But yeah, I think we do have some clues, granted to us in the 2021 season, and it might be helpful for us to start there by taking a little bit of a look back. So let's quickly go through the highlight reel for the 2021 season. If I can just advance here. Apologies. Sometimes it's sticky on the first start. All right, so we hung in there pretty good until about June. And I think that around the first day of summer, we were marked by a frost as our crops were really rolling into their vegetative stages. And that, it became increasingly clear across the province that the taps were starting to turn off. In-crop herbicide applications were also commencing around this time frame, which we'll talk a little bit more later. 2021, also notably the year of the grasshopper, and in some regions and crop types had special appearances by lygus bug pressure. As we got closer to harvest, staging challenges, lots of stress implications, and those pulse crops just trying their hardest to do a bit of regrowth, which maybe threw some wrenches in come maturity and moisture averages across the field. Also bringing with us some early seed quality hints, which we'll discuss later today. As many of you are aware, pea, lentil, and chickpea yields were estimated to be about 40% lower than the 10-year provincial average. And then finally, as we roll into fall, there's some stories that accompany with soil sampling, fertilizer, and rotation planning. Implications for the 2022 season. I guess for starters, say what you will about last year, but it did give us a bit of a masterclass in terms of physiological crop stress. So, not a fun one to go through, but I think there were certainly some learnings that we can look back on. There's some implications for seed quality and, of course, seed quantity with yield and quality parameters. And then, of course, the larger bucket of rotational considerations, thinking about herbicide, nitrogen carryover, and then the long-term sustainability of the pulse acre. So starting off at the beginning of the season, we did encounter some of that frost both during establishment, but then had another hit a little bit later. And that late frost was really one of the most widespread temperature stresses posed on our crops. So before heat became the story. As mentioned, many of those crops were progressing through their vegetative staging when temperatures took a dip. And, there were some really visible growth impacts. The good news story is that our pulse crops do have the ability to recover from frost when they're at that vegetative stage or just headed into flowering. But in order to do that, there can be a little bit of a delay. Resetting some of those flowers, setting new leaves and main stem nodes. So it's a little bit of an energy penalty as well as a bit of a delay. And I think a lot of the initial concern was that the delay may set them too far back, especially in some of the shorter season areas. But as you're aware, from that perspective, it turned out that wasn't our biggest concern of the season with harvest sort of getting into full swing quite early. On the flip side of the coin, our pulses do have the ability to tolerate, quite a bit of heat stress. But under those prolonged periods, above that 27, 28 degrees Celsius, there is a flower abortion risk in many of our pulse crops, chickpeas having a little bit of an advantage relative to faba, pea, and lentil. But generally speaking, too hot for too long can be a bit of an issue. We also had a chance to look at heat impact on chickpea through a collaboration project this year with Crop Intelligence. And so a bit of a snapshot here, certainly not the whole yield story by any means, but I think a little bit notable to point out as the number of days and hours above 28 degrees also seems to trend with decreased yield. And the lowest yielding site actually seen 100 extra hours above that 28 degrees Celsius relative to the highest chickpea yielding fields in this project, and had 10 extra days of above 28 degrees Celsius temperatures in July alone, really at sort of the peak flowering and pod setting time. So some interesting insights there, and thank you to Crop Intelligence for that. Water use, certainly another part of the story here. I think it's always top of mind in any season, how much moisture we're getting and how much moisture our crops are accessing, but certainly a highlight this season. So, you know, our pulses are generally well adapted to drier conditions and can tolerate a certain degree of drought stress. From a water use efficiency standpoint, we'd consider them about middle of the road relative to oil seeds and cereal crops. You know, when we put that in perspective of how much yield is built per inch of crop water, as denoted by these graphs here. So on the, you know, average end, probably about 4 to 6 bushels per inch of crop available water in our pulses, whereas in our cereals, they're probably at 6 to 12 if they can get sort of off the ground and get that moisture happening. How did this tie into the yield response story? I think something that everyone is all too aware of, maybe where the yields lied. Across the board, we're certainly below that 10-year provincial average. So on this graph, that's denoted by the gray bars, with the green bars denoting our 2021 provincial average yield estimates. And we see a fair bit of a gap kind of across all of our crops. The red line above is really denoting sort of that percent yield decrease relative to our historical mean. So in this case, the higher the point, or the higher the part on the line, the deeper the yield decrease. And we see quite a range from about 27% off of what's expected yield of those crops to about 58%, with our peas and lentils somewhere in between, and our chickpeas trending just a little bit higher than that. We hone in a little bit deeper on maybe one specific region, because again, the story is going to differ across crop district and of course across farm and regions specific. But the Southwest region was arguably our hottest and driest across the 2021 growing season, and there we start to see a little bit of a bigger spread between our peas and our lentils, with closer to that 40–47% yield decrease across expected, whereas some of our other crops were showing 50–60%, again with chickpeas trending a little bit higher on that front. So arguably, you know, less grain going into the combine this season, but what about the quality of that seed coming off the field? So one parameter of seed quality is seed-borne diseases, and each year we partner with commercial seed labs across the province, or prairie seed labs that take seed samples from Saskatchewan producers and do a survey of seed-borne diseases that helps us sort of track seed quality over time. So this data is based on those interim results, and special thanks to Discovery Seed Labs, Prairie Diagnostic Seed Labs, 2020 Seed Labs, and Lendon Seeds for their contributions in this survey. And a really good news story from a pathogen standpoint, and probably not surprising to anyone. The colored bars showcase the percentage of pathogen-free seed. So the higher the bars, the less disease that was showing up on the samples as a whole. And really, in a lot of regard and a lot of pathogen types, we've seen very very clean samples with almost 100% of them in some cases having no pathogens. The dark black dots are the mean infection levels of the samples that had some level of pathogen detected on them. And really, again, they're falling within or below typical accepted thresholds for seed-borne disease. The one maybe thing to note is ascochyta, seed-borne ascochyta in chickpeas. It's trending just a little bit lower in terms of pathogen-free seed and a little bit higher in terms of mean infection at 1.3%. So indicating that the seeds that did have some level of detectable ascochyta are certainly above that threshold of 0.3% that we would accept for seedable chickpea seed. While seed-borne disease levels are low, you know, seed quality still might not be all it's cracked up to be, and excuse the pun there, but we are seeing reports of below average germination levels, particularly in peas. Vigor also taking a little bit of a hit as well. So if a seed test isn't something that your farm has done just yet, I would certainly encourage you to get one to a lab sooner than later to know what you have available for the upcoming season. A lot of this is attributed to high levels of mechanical damage, and you know, as we continue to handle those seed lots, increased damage is probably an expectation. So again, if you haven't seed tested, would certainly recommend getting a baseline one. But for those of you that have submitted a seed test, I think a good practice to follow up with a sample in the spring to recheck for those germination and vigor levels. Not only do we have to identify, you know, what we're going to use for seed, but also where we're going to put it, which becomes the next part of the equation for 2022. As you're aware, drought conditions have led to above average herbicide carryover risk. And this map produced by the Saskatchewan Ministry of Agriculture does a pretty good job of snapshotting where our most extreme risks for herbicide carryover are based on rainfall data from June 1st to August 30th. And as you can see, with the exception of a larger pocket in the southeast region, majority of the province is under elevated risk level for herbicide carryover. So, you know, we talk a lot about precipitation in that regard because one of the major degradation pathways for herbicide is that microbial pathway. And so the microbial activity requires moisture, temperature, and time. And it's going to require more time in absence of moisture and temperature as cofactors. It's also influenced by different soil properties, such as pH, soil organic matter, and soil texture, and those are going to have different interactions with various active ingredients. And then really important to note is the risk is going to vary from farm to farm, field to field, and then even within landscapes, right? We don't have uniform soil types across all of our landscapes. So this is one that's really tricky to pin down. But I think the takeaway is that herbicide carryover is something to consider for 2022. Of particular note is herbicide carryover of imidazoline-based active ingredients, such as those found in products like Solo or Odyssey, among others. This graph just shows the relative crop sensitivity to IMIs, IMI residues, starting with our small seeded oil seeds on as most sensitive, all the way up to our pulse and clear-field crops as having the least level of sensitivity and being the most tolerant. You know, so there might be some temptation to plant back onto that ground sprayed with IMIs with either a pulse or another clear-field crop again in 2022. And, you know, advocate to not do that. Ideally, that rotation would probably be avoided, particularly the pulse on pulse. But if we do need to go back in with IMI tolerant crops such as a pulse or another clear field system, really need to focus on managing them conventionally without the application of another round of IMI herbicides. This is important from a resistant management standpoint and also to avoid stacking and compounding an already existing herbicide residue problem. Important to note that pulses are sensitive to other active ingredients, so they might be the catalyst in the story of the IMI carryover, but we do have to take into note the actives that irritate them. So just for one example, group 27 herbicides, such as those found in affinity, can be a problem for follow pulse crops. So these are showing some symptomology of that affinity carryover on lentils, peas, and then faba. Others of note, flucarbazone, a different group 2 on peas, really showing that stunting and tillering, as well as metsulfurion and faba on the far right side. Group 4 and 26 conclorac carryover on faba bean, as well as clopyrrolid carryover on peas, which are notably one of our more tolerant pulses to clopyrrolid, with lentils and chickpea already having a recrop restriction of more than a year. But we can really see this elevated, especially when moisture the subsequent season is reduced. The key takeaway is really know before you grow. Certainly didn't cover all of the groups and actives that could potentially lay out a problem. So really encourage growers to look back on the records and know what was applied and the environmental conditions after that application. And then of course consult, with manufacturer, local agronomists, to ensure that you're not planting back into a field that has suspected herbicide residues that could potentially pose a damage to your pulse crops. Herbicide carryover, not the only residual in our minds this year. So in some cases, there might also be excessive N in the system, and we have a little bit of work has been done on that. So this research shown here is based on some work that was conducted in the late 80s and looks at the impact of background N on lentil and grain yield. And one of the findings from this study was that seeding lentils into those soils testing higher for nitrogen, so they had treatments from 0 kilograms per hectare all the way up to 90, which roughly translates to pounds per acre, did not negatively impact yield or maturity of lentils in this study, but may result in reduced nitrogen fixation. So as you're aware, our pulses are really good N fixers, variable amounts across species, of course, and across seasons. So different conditions are going to impact their ability to fix nitrogen. But as a general rule, when inoculated properly, we're expecting about 50 to 80% of our nitrogen requirements to be met through nitrogen fixation. As that soil available N or combinations of soil plus fertilizer N start to get above 50 pounds per acre, that's where we'll see a significant reduction in N fixation. But of course, our pulses need nitrogen, so they can make their own, but that doesn't mean that they're a low nitrogen uptake crop. In fact, relative to canola, which we often consider as a crop that's a little bit higher on the total N uptake per bushel, we see a lot of our pulses fall right in line or maybe even have higher N requirements. So the difference in this case is, they'll take the lazy way out. They'll use the inorganic N from the soil opposed to expending that extra energy to send photosynthate to rhizobia to fix N from the atmosphere. So it's not necessarily agronomically the worst case scenario to seed on high N ground. It is obviously a bit of an economic disadvantage when we think about pulse crops being able to supply their own nitrogen. So while it can be done, there are a few caveats. We really want to consider canopy management as we're possibly seeding pulses into soils with higher levels of soil residual N, because typically we will see a dry matter increase, bigger plants, more biomass, and that isn't going to be static across all growing areas as well too. It's really going to have an interaction as well with environmental conditions. So that nitrogen, that luxury nitrogen will certainly be put towards more biomass as we get lusher growing season conditions too. So we need to account for that increase in biomass, particularly from a disease pressure perspective. We're going to have, you know, a little bit more of a humid microclimate. If we're making fungicide applications, really need to err on the side of preventative and make sure we're making those applications prior to row closure, which might happen quicker if there's more luxury N in the system. And also consider some differences between your type of pulse crop. So just for one example, a large green lentil is certainly going to be more responsive to this extra N relative to a small red lentil. So, you know, in response to those rotational challenges, whether it be herbicide carryover, nitrogen carryover, I think there's been a few ponderings of whether to seed back-to-back pulses. And coming off such a severe drought, it might be easy to forget about the risks of those intensified pulse rotations in a normal to wet moisture year. These photos are taken from a lentil fields with adjoining management in West Central Saskatchewan, and I think it's probably pretty easy to spot which one had the extra year of pulses. So the photo on the left side of the screen is certainly struggling a bit more from a root rot perspective, with a lot of Aphanomyces pressure in this field, relative to the photo on the right, which actually just had a slight tweak in its rotation of one less pulse across the board, and is definitely faring quite a bit better in a moderate wet year of 2020. So as you're planning your rotations this season, I really encourage you to consider all types of carryover, herbicide, nutrient, and disease. And maybe you're in a region where lack of moisture is a bigger concern than disease, but I think there's still value in considering, you know, stubble rotation, specifically from the perspective of soil and moisture conservation. So these, you know, diverse rotations and differences in stubble and crop types leverages differences in crop rooting depth and their ability to extract water from different parts of the profile. So for instance, pulses can extract water from a shallower depth and may leave more water in the soil for the following year's cereal oilseed crop. On the flip side of this, our cereal stubble, our oilseed stubble potentially catches more snow, and in some regions that snow catch is where we're receiving quite a bit of our moisture from. So this photo is actually from a hydrologist, Philip Harder. If you haven't caught his musings on Twitter, I certainly encourage you to follow him. He does some excellent threads explaining different snow measurements as well as different hydrological aspects. But this photo here is just showcasing the pea stubble, which had lost about 47% of its snowfall due to sublimation and blowing snow erosion, relative to the cereal stubble on the other side, where increasing snow catch efficiencies through stubble height and moisture retention and maximized residues all sort of play into the total moisture conservation part of your rotation. So fields in continuous pulses may be at a greater risk of soil erosion and topsoil loss if it's a continued practice. I'm getting to the end of my time. Just part with a few concluding thoughts for those key considerations for 2022. You know, we really need to carefully consider crop rotations and identify the least risk for your individual farm. Really not cookie cutter answers heading into next season, but there's a lot of things to weigh. Of course, herbicide residues may persist for longer during a season of drought, and pulses can be susceptible to injury. Also figuring out where to fit pulses into that rotation when you're juggling other carryover concerns. Seed supply is set to be low and seed quality might be subpar, possibly declining when we think about further drops over winter storage. crops are tough, and arguably so are those that grow them. So 2021 left us with a lot of lessons to prime us for 2022, and I think you know, we're in good shape to learn from those, and I just wish everyone the best of luck as they head into the 2022 growing season. Thank you.
Thanks, Sarah. And again, if you have some questions for Sarah, you can type them in the question box and we'll address those in the first question period. Our next presenter is Melanie Leppa, owner and agrologist with Soils and Such Agronomy. And she's going to be discussing growing chickpeas 101. Melanie grew up on a grain and cattle farm near Swift Current and attended the University of Saskatchewan, obtained her Bachelor of Science in Agriculture, majored in soil science in 1995. Melanie has worked at Saskatchewan Pool and Viterra as a manager of agronomy services, as well as a local independent retailer. She started her independent consulting business, Soils and Such Agronomy Limited, in 2013. Melanie provides her customers with soil sampling, crop planning, record keeping, fertility recommendations, and crop scouting. Melanie and her husband Scott reside on her great-grandparents' homestead along with 4 children. When not busy in the field, she can be found helping out with activities at the local school or helping kids become leaders for tomorrow in the local 4-H club. Welcome, Melanie.
Thank you, Corey. And welcome to everyone who's joining us today. Can you hear me and see my screen okay?
We sure can. You're good to go, Melanie.
Awesome. Way better than last year. So Sask Pulse Growers asked me to kind of give an overview of how to grow chickpeas. So I kind of did it from an agronomist's perspective and in helping a grower try to plan to grow chickpeas for a season. So for the people on today that are seasoned chickpea growers, there's nothing new to see here, but for the new growers, this will be hopefully an overview of what you need to think about. So you have to ask yourself, are chickpeas for you? And there's a few questions that come along with that. First of all, you have to love your sprayer because you may spend a lot of time in it and you're going to need access to a lot of water if you have to spend time in your sprayer because of disease issues in chickpeas. That is one of our biggest challenges. You're basically signing up to be a babysitting service if you grow chickpeas. So if you don't want to do it, you may need to find someone to help you along with it because they do require a lot of scouting. And you do need some patience to be a good chickpea grower. So if you have the patience of a saint as well, chickpeas might just be for you and your farm. So let's dive right in. Some things to think about with chickpeas is what kind you want to grow. And there's 2 types, kabuli or desi. Kabuli are definitely the most common type and they're the larger seeded type. Those are the ones that I deal with in my business. I don't have any desi growers right now and haven't had for several years, but so you need to think about where you would like to grow these chickpeas on your farm. And when thinking about that, I encourage growers to think about their soil types. Chickpeas do well in loamier soils, lighter soil textures versus heavy clays. You also need to think about the landscape of your fields. You know, flatter land or slightly gently rolling land is maybe a better choice than something that's drastically hilly because they are long season crop and they like moisture. So in the low spots, they'll take forever to come in if it's a really swingy landscape. If you have neighbors growing chickpeas, you need to think about what's going on around your fields. You want to try to avoid bumping up against your neighbor's chickpea stubble. Or even if you have more than one chickpea field on your farm and you're moving forward with your rotation, try to avoid bumping up against chickpea stubble from a disease management aspect. Chickpeas do not do well in saline soils or waterlogged soils. And the one benefit of chickpeas in rotation is that they are an alternate crop choice for Aphanomyces infested fields. So it might be a pulse that more people are starting to think about again. It's been a long time since a lot of growers have grown them, but they're coming back into the thought process. Another thing to be aware of with chickpeas is their days to maturity, and they are an indeterminate crop, so they will grow forever until they receive some form of stress to kind of turn the tides and ripen. So some years they will ripen in 110 days, but I've seen them take a lot longer than 130 days before too. Some years they just don't want to die. So things to be aware of or think about a little bit. I know for years they were touted as a super drought tolerant crop, and they are, just maybe not quite as drought tolerant as we initially thought. They are tap rooted, so they can root down into moisture, but we have to have moisture there for them to root down into. So we learned this past season that there was no moisture down there, so chickpeas kind of took it on the chin as well. And we've seen that in Sarah's information too. Hot days and lack of moisture, they struggle just like any other crop would. So they are susceptible to heat stress as well. Just like any other pulse crop, they can abort flowers and abort pods. And if you're a chickpea grower, you will find empty pods in your field, whether it's good conditions or poor conditions. It's just one of those things we see or I see in every single chickpea field. Not huge amounts, but you'll see it to some extent every year. Another thing to be aware of is your expectation level for the crops that will follow chickpeas on your farm. I've found that chickpea stubble is dry as a bone most years, and it seems to be slower to cycle nitrogen back into the system. So we try to set our expectation levels just a little bit lower on chickpea stubble most years, unless if it's a super wet year, it's not as much of a big deal. But some years our follow crop isn't quite what we expected to be after chickpea stubble, and I just don't want that to be a surprise for anyone the first time they grow them. So from a yield standpoint for chickpeas, I dug into the Sask Management Plus data. I figured that was probably the best for a wide audience, and 5-year average yields for kabulis are somewhere in the mid-20s. I suspect that's going to drop a bit after last year, but I've seen kabulis yield anywhere from below 10 bushel to the acre to somewhere over 40 bushel to the acre, depending on the year. There wasn't really enough data on the desis to get a true great average yield, but somewhere in the mid-20s would be a safe number for the desi types. So the big thing I think you need to really think about if you're thinking about growing chickpeas is the economics of them and your budget. You need to sharpen your pencil and know what you're getting into. Your fungicide budget will be the biggest part of your budget. We're looking at $20 plus per app, and in some years up to 4 or maybe 5 applications of fungicide. So that's a big cost. There's a lot of time spent in these fields too. And know your cost of production. Seed treatment is not cheap on them either, because we seed them at fairly high rates as well. So just really do a pencil sharpening session with the economics and your budget if you're getting into them. You don't want to start off short because you can't afford the fungicide options if you need them. So I've kind of made a checklist of things to think about as a chickpea grower once you've decided to grow them. And first and foremost is good quality seed. It's extremely important to have low ascochyta levels in your chickpea seed. I actually encourage 0%. I know 0.3% is allowed, but I really encourage 0%. And really good germ and vigor. Chickpeas are slow to get going and slow to get growing, so it's pertinent that we have good quality seed. When it's time to seed them, they're maybe not the best choice to seed first. They need a nice, warm, moist seed bed. It's really critical for getting them up and out of the ground, and they need good seed to soil contact. So they'll get growing a lot better if we wait for those soils to be on the warmer side versus say a 2-degree soil. The research shows that they do best at 10 degrees soil temperatures, but I don't know really any growers that wait for +10 for their chickpeas, but definitely don't want to be out there when it's +2 in the soil temps zone anyhow. So the other thing is seeding rates. They can vary quite a bit from seedlot to seedlot and from season or year to year. So I encourage everyone to get a good 1,000 kernel weight on your seedlot. So wait until after you've cleaned them to get your final 1,000 kernel weight before doing your seeding rate calculation, because chickpeas will grow to varying sizes, anywhere from like 7 millimeters or lower down up to 10 millimeter size chickpeas. So you want to wait till you've got your seed lot cleaned before you do your calculation with your 1,000 kernel weight. And I target somewhere in and around that 3 to 3.5 plants per square foot. So it doesn't look like there's a whole lot out there for a long time, but eventually they do grow up and get big and get bushy. When it comes to choosing inoculant for chickpeas, it's a specific strain that is not inherent in our soil, so it's not native to our soils. So when you go to your retail to buy inoculant for chickpeas, you need to make sure that you do get the chickpea strain. And from what I found, most growers prefer to use granular inoculant on their chickpeas. It seems to be the easiest to use. When it comes to seed treatments, the Kabuli type have a low tannin seed coat. That's why they're kind of that lighter color. And they're very susceptible to seed-borne or soil-borne funguses, especially Pythium. So seed treatment is a must on the Kabuli types, 100% absolute a must. And you need really good coverage to get in all the nooks and crannies on those seeds, because they're kind of like bumpy little brains. So good coverage is really key. Seed treatment isn't as pertinent on the Desi types, but if you're seeding them on the early side, it's definitely a must as well.
Hey, Melanie, this is just a warning that you have 4 minutes remaining.
Okay, for the fertility side of things, I encourage growers to choose fields with a lower N status. As with any other pulse crop, most growers choose to use a phosphate starter blend. Chickpeas are very sensitive to seed-placed fertilizers, so you need to be cautious in your rates. I believe it's documented up to 20 pounds of P2O5 is safe in the seed row, depending on what your opener is. So just be aware that they're sensitive. And it's interesting, some growers choose to avoid inoculating and just use urea or nitrogen fertilizer as a risk management tool. I have most of my growers still use inoculant, but I know a lot of growers that do use nitrogen, and the theory behind it is to just feed the crop a certain amount of nitrogen to encourage it to kind of come in at the end of the season. It needs a stress to make it turn the tides towards ripening, so it runs out of nitrogen and starts to come in. So that is definitely an option, and it works for growers. Some of the challenges of growing chickpeas used to be weed control. Things have come a long way over the years, so pre-emergent products are key. All of these listed here I've seen with chickpeas, and they work quite well if we get moisture to activate them. Because our in-crop broadleaf choices are really slim, we essentially have 2 choices in crop, one being Metribuzin, which is Sencor, and there's a new product out, Tough, and I didn't get to see Tough this past season, but I hope I get to see it this year. At least it's nice to have another option in our toolbox. And when it comes to grassy weed control, we basically have all the group 1s, but one thing that may or may not be good, depends on where you sit on the whole Clearfield side of things, but the new varieties are all coming out as Clearfield tolerant. So it does give you another option for weed control. Not to scare you, but the biggest nightmare with chickpeas is disease, and that's Ascochyta. It's a challenge to manage, and it seems to happen just about every year to some extent. Even in the drier years, we'll find a little bit of it. My photos there on the screen on the left is what I consider the resistance mechanism kicking in. Those are little spores that have landed and the plant has stopped it from going anywhere, but it doesn't take long for chickpeas to grow out of that stage, and you'll see lesions occur. And if moisture conditions are correct or wet, I guess, then we move into stem lesions, and that's when yield loss can happen. So it's good to get your head around fungicides and choose your products wisely. Start early, somewhere between the 8 and 10 node stage, depending on the year. Some years we can push that to 11 or 12 nodes if it's drier. Watch your weather forecasts. Try to get in there before weather events happen versus after. It's always better to be in with a protectant fungicide before it rains, especially because Ascochyta is much like fire in chickpeas, and scout. Also be aware that there's been a survey initiated by Michelle Hubbard at Ag Canada, and she's found that there's a lot of strobe resistance in all the populations out there. So we're losing an option, much like we are in lentils with Anthracnose. So scout is my advice to anyone growing chickpeas. So sclerotinia is another disease we see occasionally, but usually just in the wetter years and mostly in the low spots. One of the last challenges with chickpeas is insects, and they're really not a big challenge. It's good to be aware of them. As you can see from the photo below, I have found wireworm burrowing right into chickpea roots. They don't seem to really slow the chickpea down too much because I think the root is just so big. There's lots of eating they can do. And every year I always find some of this feeding on chickpea roots above the soil surface. And I wonder if that isn't some cutworm damage in there as well. Grasshoppers are rare in chickpeas, but honestly, if there's nothing else to eat, I suspect they'll eat them too. And this past season was the first year I've ever heard of gophers actually taking out an entire chickpea crop. So, and they are definitely increasing in number, so that is something to be aware of as well. Harvest can be a bit of a challenge. They don't always like to mature. Lots of years they do, and we don't have any issues with them. But if you get some rains in July, later in July or early August, pretty much know you're going to need to set yourself up to do some form of pre-harvest activities out there. So glyphosate, which is great if you have perennial weeds. It's slow. It'll stop this new top growth from happening. But it's going to be a long, slow process. If you look at using Raglone or glyphosate in heat, you're basically waiting for the crop to be 100% ripe and just knocking off the tops with those products. But so you just need to prepare to do that if you need to, so it doesn't kind of throw you off your game late season when you think they're done. So with that, I'll just conclude with some top tips for successful chickpeas. First and foremost, quality seed. Good germ, good vigor, zero ascochyta if you can. Choose your fields wisely, especially if it's your first time growing them. Maybe try a flatter piece of ground with a lighter soil texture. Prepare for weed control. There's options for spring. I prefer fall applications just so we know that they're activated come spring. Prepare for timely disease management, especially this season. If you're going to grow them, get some products on farm so you're ready to go and can move quickly when you need to. And don't be shocked if you need to do some pre-harvest operations if we get some later season rains. And with that, I wish everybody who delves into chickpeas some good luck and happy scouting. Thanks.
Thanks, Melanie. As a non-chickpea grower, I found that really interesting. And so yeah, some good information. And again, if you have questions, just throw them in the question box and we'll deal with that after the next presentation. So our next speaker is Michelle Hubbard, a research scientist in plant pulse pathology with Agri-Food or Agriculture and Agri-Food Canada. Michelle Hubbard is based in Swift Current, and her research focuses on anthracnose of lentil, ascochyta blight of chickpea, and root rot in pea and lentil. She hopes to help pulse farmers find novel, practical, and sustainable ways to control these various crop diseases that we deal with. Michelle is going to be first talking about lentil anthracnose. So with that, welcome, Michelle.
All right, thank you, Corey, for that introduction. Can everyone hear me okay and see my screen?
Yeah, it looks great. Go ahead, Michelle.
All right, so as Corey said, I'm going to be talking to you now about lentil anthracnose and what you need to know. And, okay, there we go, didn't want to advance. So I'm going to give a brief overview of lentil anthracnose, some management considerations, and then really delve into fungicide insensitivity, what it is, and the latest research, and then wrap up by some of my thoughts on what you as a lentil grower or agronomist can do. So first off, what is anthracnose of lentil? As I'm sure you all know, it's the most important foliar disease in lentil, and it's caused by the fungus Collectivum lentis, or C. lentis. And it causes symptoms that typically start low in the canopy and can include stem lesions as well as water-soaked lesions on leaves. And as it moves up the canopy, it can lead to leaf drop. And if the symptoms become severe enough and actually girdle the stem, meaning they wrap up all the way around the stem, they can cause lodging, as the stem might break or nutrient supply could be cut off to the upper part of the plant. The anthracnose life cycle involves survival of pathogen inoculum, or the spores, from year to year, and then once the spores are present and lentils are present to be infected, infection can spread from plant to plant multiple times over the growing season by wind or rain, spreading the inoculum from one plant to another. And so some of these pictures show just a microscope image of a spore, and then more advanced lesions where you can see the microsclerotia or the little black dots in which spores are produced. And as I'm sure you're aware, especially after last year, the environment can have a big impact. And as with most diseases, a wetter environment tends to promote disease, and more extreme temperatures, such as cooler temperatures or extreme heat, can reduce disease. And then in terms of management options, fungicides are important, but before you decide about a spray application, scouting is also important. And if you do decide to spray, it's important to do it early as a preventative spray and before the canopy closes around flowering. And this is in part to ensure good coverage with your fungicide, that you can actually get into that lower part of the canopy where the disease is. And then, as I mentioned, the inoculum or the spores survive in the debris over time. So this leads to the importance of a good crop rotation and not growing lentils multiple times in 4 years. There are varieties with genetic resistance to Anthracnose, but this resistance is only against the less common and less virulent or less disease-causing race 1. So even if you choose a resistant variety, you're still at risk. Other strategies could include doing what you can to avoid a very dense canopy, so not planting too densely. And something that I think may have potential is intercropping. I say may because intercropping can help with some other foliar diseases, but there's really no research as yet on its impact in lentil. And if you do decide to try intercropping, I would love to hear about it because it's an area that I'm very interested in. So now to move into fungicides, they are a very important tool that's commonly used for managing anthracnose. They can act in many different ways and are classified based on active ingredients that can fall into various groups. And for those that manage anthracnose of lentil, strobilurins or group 11s are the most prevalent and the most common, followed by group 7s or succinate dehydrogenase inhibitors, and then group 3s, which are demethylation inhibitors. And then another option is M5 or M3s, which are contact-based. And so group 11 is what I'll be focusing on most in this presentation. And then next most group 7. And those two are linked in that they both act on respiration. And so then fungicide insensitivity is basically this diagram gives a little bit of an indication of how it can occur, that you have a population that initially is mainly sensitive to a fungicide, but there's a few members of the population that have insensitivity. After a fungicide is applied, most of the sensitive fungi are killed, leaving you a higher proportion of insensitive. And then as the fungus reproduces, the population shifts to be a greater and greater percentage of insensitive. And then, of course, if you apply fungicide again, this shift will only be accentuated. And then certain fungicides are more at risk for resistance developing to them than others. And group 11s are at the highest risk, in part because there's just a single mutation. So change in one base in DNA can lead to pretty much total resistance to this group. And then group 3s and group 7s are at medium risk. And then the contact-based M5 and M3 group are at a lower risk. And so then more specifically for lentil, the table on the right shows the fungicides registered for anthracnose of lentil. And so there's some that rely only on a group 11, and then there's some that rely only on a mode of action other than group 11s, and then another group that have a mix of modes of action. So a group 11 with a 3 or a 7, or both a 3 and a 7. And as you can see,
Michelle,
yes,
you have 5 minutes remaining.
okay, thank you. And then in 2020, I found that indeed group 11s were widely used. And so over the last 2 years, I've led surveys that found a lot of anthracnose in 2020 and less in 2021. So I'll focus more on my 2020 results. But before I get to that, here are some results from Dave Greenshield of Insight Plant Health that basically demonstrate that any fungicide, when the data was grouped across all plants and all types of fungus, so both sensitive and insensitive, that any fungicide was better than none. And when you look at it in terms of the groups, you can see that when only a group 11 was applied, that was less effective. Whereas when there was especially a contact-based fungicide involved, the disease was less. Then this graph is also work done by Insight Plant Health, and it's comparing the impact of fungicides on sensitive versus insensitive to group 11 anthracnose fungus. And the ones I'm highlighting now are, as you'd expect, if you apply only a group 11, the sensitive fungus is controlled better than the insensitive. And this also illustrates the point that it doesn't help, or it's not different to use different active ingredients that all belong to group 11. If a fungus is insensitive to one, it's insensitive to them all. Then what stood out to me here is when a group 11 and a group 7 were combined, we saw the same thing. So this made me wonder, might there be resistance out there or insensitivity out there to group 7s? And this is a growth chamber, not a field study, so more work perhaps needs to be done, but it's made me suspicious. And then this picture illustrates what anthracnose looks like on plates, and also again the cross reactivity. So if it doesn't grow, so if we have an insensitive fungus, it grows regardless of the type of group 11 you used. And if you don't have, and if the fungus is sensitive, it's killed by any type of group 11. Then these data come from my 2020 field survey, and these results are consistent with what private industry has found, and importantly that insensitivity to group 11 fungicides is widespread across the province, and that far more samples had insensitivity than didn't. So from a given sample, based on a DNA-based assay, the possible results is just being sensitive, just being insensitive, or both within the same sample, or occasionally a inconclusive result. We also looked from each field. We've analyzed samples from 4 sites for some of the fields. And here we found that there was a lot of variability within fields, and that there was only a minority of fields where there was only sensitive isolates. So only 6 fields where there were 4 sites where all were sensitive. But for a change, a little bit of good news, that I did find that at sites within fields where the isolates were insensitive to group 11 fungicides, there was actually less disease. And so that brings me to future plans, which, as I hinted at earlier, I think a high priority is screening in vitro, so on Petri plates, for insensitivity to group 7 fungicides, which is complicated because unlike group 11s, the reaction might be different depending on the active. And then I plan another field survey for 2022 and want to delve in vitro to look at the relative growth of fungi that are insensitive versus sensitive. And so, as I would be wondering if I were a grower, what can you do? You can assume you do have insensitivity to group 11s. And if you consider using fungicides that don't have a group 11 active, definitely don't do 2 applications of fungicide that contain a group 11 within a single season. If you apply a fungicide, do it early before canopy closure and keep track of what you've done. Use good crop rotations. Do what you can otherwise to maintain a healthy crop in terms of weed control or fertility, etc. Consider trying intercropping, though I would advise starting small if you're new to it. And to facilitate the survey that I'm planning for 2022, I'd encourage you to sign up for the pest monitoring program online. And so you can use this QR code or link. And this is what the form should look like when you access it online. And with that, I'd like to acknowledge the many people in my group who made this work possible: the Government of Saskatchewan, Ministry of Agriculture, Saskatchewan Pulse Growers, of course, and ADF for funding, and then the private industry agronomists who conducted the survey work. And that wraps up my presentation on anthracnose of lentil.
Thanks, Michelle. Yeah, really important area for now that we're sort of well into lentil production in Saskatchewan. So sort of the holiday, if you like, of no disease is long past, and we've really got to start paying more attention to these issues. So the second thing that we would want Michelle to talk about this morning deals with the chickpea health issue that has arisen in southern Saskatchewan. I think it's 3 years really now that that's been happening, and we've ramped up efforts on a number of fronts to try and determine what all is going on with chickpeas. And certainly Saskatchewan Pulse has been putting a number of resources into trying to get to some more concrete answers about that. So next we'd just like Michelle to talk about her involvement in that issue and what you can share with growers that you've learned so far. So carry on, Michelle. Thanks.
All right. So I hope everyone can see my slides again with the chickpea emerging health issue.
Yes.
Great. All right. So there's a lot going on with this. So it was a bit of a challenge to condense things down to a 20-minute presentation, but I've done my best. And so first off, I'll introduce a little bit about what I'm talking about here. What is this emerging health issue and what can it look like? So one of the typical symptoms we've seen is plants dying at the tip, or apical death. And though Melanie mentioned that shriveled pods can happen in any chickpea field, it can also be associated with this emerging health issue. Sometimes it's also very variable. So while an entire field can be affected, it can sometimes occur in just isolated plants, and it can impact just the apex of a plant, but then as it spreads, it can impact a large area of the plant. It can also include leaf tip whitening or chlorosis or death of branches. And then, as Corey mentioned, it has been going on for a while now. So I thought I would include a little bit of a history and brief of the issue. So it first came to people's attention, and specifically to my attention, in mid-July in 2019. And it really did a lot of damage at this point, as you can see from Eric McPeak's photo here. And it was first noted in the Assiniboia, Coronat, Gravelbourg area of southwest Saskatchewan. And at that time, it was thought to be linked to ascochyta blight, because there certainly was severe ascochyta blight, which, as Melanie mentioned, is a huge problem in chickpea. So that led to the thinking that perhaps the genetic resistance in the Kabuli cultivar CDC Orion was breaking down. And this was partly because, as my other picture here shows, Orions did a lot worse in that year in some instances than Leader, the other widely grown Kabuli cultivar. Another suspect was group 14 herbicides and or the environmental conditions. So it had been dry early on in the season and then wet right before flowering when this condition was first noted. And so perhaps that environment played into it. And I'll come back to environment later in this talk. Then in 2020, the Saskatchewan pulse growers led a survey. And this survey involved samples being collected by agronomists from 27 fields and analyzed in many different ways, including agronomic info being collected, herbicide residues being tested for disease, being tested for nutrients and nematodes, as well as other insects, and a microbiome analysis. And an excellent report is available online about different details of these results. One thing that I wanted to highlight is that in certain fields, there was very high levels of nematodes, including the pin nematode, that the picture of which is shown here. And that work was done by Mario Tenuda's group. Though Mario didn't feel that the symptoms we're seeing are those that are typically caused by nematodes. Then some more testing was done of the soils for 2020, and Dr. Jeff Shano's group tested a suite of soils they did a sugar beet assay, which was intended to pick up herbicide residue, but may also have picked up nematode issues potentially. And they did find that one of the soils from affected fields, the sugar beets grew far less. So that does suggest that it could be soil-borne in some cases, but likely not in all cases. In 2020, some insect issues were also identified, feeding on nodules, and James Tansley and Dr. Sean Prager's group identified 2 insects, a seed corn maggot and a fungus gnat. Then the microbiome analysis that was done by Dr. Jennifer Town at AAFC and Swift Current found, for most of the analyses she did, that there was really no difference between healthy and unhealthy samples. But she did find that in the plant samples, there were 2 fungi that were associated with healthy samples. And that's a little puzzling because Fusarium hostae, one of them, can be associated with root rot in some plants, though not typically chickpea, though I did find one paper about it causing root rot in chickpea in Iran. But here it's associated with healthy samples, so it's puzzling. Or with a species that's linked to Fusarium avinaceum, which can cause root rot. Then in soil samples, there were 2 species that were linked to unhealthy soils, which Pythium is perhaps not so puzzling, as we know Pythium can cause seedling and root issues in chickpea. But then the other species is more often linked to healthy soils. So it's puzzling again. And there is the caveat that this was a small sample size, and the DNA extraction was not done in the town lab. Then this brings us forward to this past year, to 2021, where myself and Dr. Sean Sharp from AAFC in Saskatoon led a survey on this issue, and Saskatchewan pulse growers made a very valuable contribution to this. So here, a larger number of fields, 79 fields were surveyed, and agronomic info was collected, some disease data was collected, and then nutrient and herbicide analysis is pending. And it was also linked to crop intelligence, surveyed or monitored 5 fields. So one of the findings was that Leader was grown in far more fields than Orion, which might not so much indicate perhaps that Leader is more susceptible, but rather that growers were scared off by the thinking in 2019 that Orion is more susceptible. And the issue did occur in two DESI fields, though they had relatively mild severity. So in this survey, severity was rated on a 0 to 5 scale. So overall, the severity was fairly moderate at 2.3. The geographical distribution was wider than back in 2019, but was still concentrated in that Assiniboia area. And then disease analysis hasn't been done on all the samples. It was done on a subset, and Saskatchewan pulse growers coordinated this and sent samples off to a lab for DNA-based analysis. And for the most part, there was really no difference between healthy and unhealthy samples. These samples were really nice in the sense that from each field, it was patchy. So they were able to send samples from the same, they were paired by field, and some samples were healthy and some were unhealthy. And as you can see from the yellow and the green bars, they were very, very similar between healthy and unhealthy in terms of all these pathogens. One that stood out to me as maybe meriting more thought is Pseudocladium species, that there was still, it was found in 6 unhealthy fields and only in 1 healthy field, but was still not found in the majority of unhealthy sites. So it's not like it can be the only cause. And it can, these organisms can cause black rot and leaf spot diseases, and sometimes a purpling and browning that looks similar to some of the chickpea symptoms that we've seen. So this is something that could be explored further. Then another component of the disease work on this issue has been done by Dr. Sabina Benitza of the U of S. And she's led a root rot survey in chickpea in 2020 and 2021. And her findings were that root rots are widespread in chickpea. However, I'd like to add that some of the impacted plants with this emerging health issue didn't appear to have root rot. Their roots looked quite healthy. And that some species of Fusarium were the most prevalent from the root rot. And Fusarium avineseum is probably the most virulent organism. Some important species were not detected. This one, Fusarium oxysporum, is important because it is associated with Fusarium wilt in chickpea, and the symptoms of that do mimic the apical wilting that we're seeing. However, it wasn't detected in either year. And then Verticillium dallii was detected in 2021. And this, I think, is significant because this organism is associated with another wilt, Verticillium wilt. So that's another one that might merit more exploration. And then Sabina's group plans to do more pathogenicity testing, so more testing of the ability of the pathogens they isolated to cause disease, and then eventually screening chickpea lines that are in development for resistance to root rot. Another suspect for a cause or contributor to this issue was herbicides, or is herbicides. And I mentioned that earlier with regard to group 14s. So then the table on the left is the herbicides that were used in 2021 by group. And so other than glyphosate, Sencor or metribuzin, group 5 was used in the largest number of fields. So that combined with results from an ascochyta blight survey that I led in 2020, which Melanie mentioned earlier, that so it wasn't focusing on this chickpea emerging health issue at that time, but a finding was that initially, before I did a statistical analysis, it looked like fields to which metribuzin was applied might have more ascochyta blight, but that difference didn't end up being significant. And then similarly in 2021, when we looked at the emerging health issue, but the ratings were based on excluding ascochyta blight. So if there was ascochyta blight, we asked the surveyors, don't consider that. So that it's just the chickpea health issue. And it looked, before I did a statistical analysis, like it might be more severe in fields with metribuzin, but then that turned out not to be the case. But it still makes me think that maybe it's not impossible that metribuzin is contributing in some way. And Dr. Sean Sharp of AAFC in Saskatoon is working with me on an agriculture, an ADF funded project, which part of that includes looking at interactions between the environment, so drought stress and herbicides, and seeing if we can, in pot studies, replicate this issue. And so Sean is doing an experiment on this. And initially it did look like, well, they were seeing some chlorosis and branch tip wilting. But then when he looked more closely at the symptoms, they don't actually look exactly the same as the emerging health issue. The chlorosis is more internal to the leaves, not on the tips. Then another piece of this puzzle goes back to the environment. And so in 2021, Crop Intelligence, in conjunction with Saskatchewan pulse growers, set up monitoring stations in 5 chickpea fields that were in what has historically been and turned out to be again the hardest hit area. And so they would monitor soil moisture and environmental conditions in these regions. And all of these 5 fields did turn out to have both healthy and unhealthy plants. And the picture that appears here is just an example of what that looked like. So within the same field, there'd be some plants that appeared healthy and some that were affected by this issue. And so here's an example of Crop Intelligence findings, that there are 2 fields, one near Ogama and one near Gravelberg, that had the same level of severity of the emerging health issue, but were quite different environmentally in terms of the amount of moisture and the number of hours of heat over 28 degrees, and were quite different in how the chickpeas performed in terms of how deep their roots went down into the soil. And the red in those graphs show water depletion. So in Ogama, there was more moisture and the chickpea roots penetrated deeper into the soil and extracted more moisture, whereas in Gravelberg, they didn't. They stayed closer to the surface. And so my thoughts about this is that while environment does seem like probably the most consistent thing so far, even that is probably not the whole story. And this nice graph shows the first panel parallels the graph I showed for 2019 of dry conditions early on, followed by wet. And then it's something sort of similar in 2020 with the moisture perhaps a little later and a little less extreme. And then in 2021, though, it's the opposite, that it's more moist early on and then very dry later. but yet this emerging health issue still occurred. So this leads me to future plans that we feel like this issue merits more exploration and is probably caused by multiple things. And so there's a need to keep looking at it and trying to come up with some answers. And part of the plan for that would be to continue to have a survey in 2022 and to have it largely the same as 2021, but ask for larger sample sizes, so more plant material collected, to make the nutrient analysis and herbicide residue analysis easier. We'll have more to work with. And then to continue on with more indoor pot-based experiments, looking at interactions between drought and disease, drought and herbicides, and perhaps including some exploration of nematodes.
And it's gonna be less than that.
And so that brings me to the end of my presentation on this issue for today. And I'd like to acknowledge the people in my group who made this possible, as well as the surveyors and ADF and Saskatchewan pulse growers for funding. And then some acknowledgements from Dr. Panizza's group. That includes her group, as well as input from Shamma Chatterton, another pathologist, and cultures. And so that brings me to the end of this presentation. Thank you for your attention.
Yeah.
Hey, thanks, Michelle. And again, any questions, if you want to just put them in the question box. So now we're gonna have a 15-minute question and answer period, and I'm going to turn things over to Sarah Anderson to moderate that session. So yeah, 15 minutes for questions, and then we'll have a short break after that. So Sarah, if you want to take over.
Perfect. Thanks, Corey. Yeah, and please feel free as we're going through this question period to continue to pop your questions in. And if Melanie is still on the line with us, I would encourage her to come in. We'll just do a little bit of a casual Q&A. There's a little bit of a mixed bag so far. So maybe picking up on Michelle's the chickpea health issue. One of the questions came in is there any testing being done with different seed lots pertaining to the age of seed, or maybe comparisons done with new varieties?
As far as I know, there's no testing of different seed lots or different age of seeds. If I remember correctly, there was thought about that in 2019, but I don't know if any formal testing's been done of that. Maybe, do you know anything else, Sarah, that Saskatchewan pulse grower has done on that?
Yeah, so we haven't done a lot of testing on seed, and I think there was a bit of a thought it's showing up a bit later in the season, opposed to being seed borne. I think at this point we're not prepared to sort of rule out any factor, though. In terms of the different varieties, so Michelle touched on it a little bit, but right now with the varieties that kind of are out in circulation and most popularly grown, we can certainly find symptomology on all of those main Kabuli and Desi chickpea varieties. In terms of screening for the new varieties, this hasn't necessarily shown up in breeder plots so far, but it is something that we maybe hope to have a bit better glimpse at in the upcoming season, if we can sort of position some newer, soon to come to market varieties in some of this core part of the chickpea growing area. So it's a project we're working on. Hopefully stay tuned for that.
I have a few more comments on the variety side too. That for my plans for indoor work, I am looking at comparing Leader and Orion and seeing if there's any difference. And in 2019, well, it probably wasn't actually this issue. In retrospect, the Bunnyman Turan did say that his plots by Moose Jaw did much better than those farther south. So, like the severity of the issue in the breeder plots, or it might just have been ascochyta blight in retrospect, was worse was worse in a way that correlated with where this issue was worse.
Right, okay. On that note too, and Melanie, you might have some experience with this, just covering a different part of the geography. Are we noticing any spreading or it showing up in places where we wouldn't expect? Yeah, maybe. Melanie, are you seeing it in different parts of your territory?
No, actually, I'm not. I think I've seen about the same level. It's stayed fairly consistent in the fields I've found it in. And as I go west, like out to the Alberta border, I can't find it out there. So I'm still going to continue to keep looking for it, but it hasn't really seemed to appeared way out there, just kind of in the deep south over here.
Okay. And Michelle, does that kind of reflect that we've expanded the survey area a little bit, but are your thoughts that are kind of first and worst are still in that core south of Highway 13?
Yes, that like I do have, I'm looking again at my slide about it, and there were some fields out in the west area, but not so many and not as severe. So it does seem to me that it's concentrated in the Assiniboia, like in the deep south area.
Okay, perfect. A question regarding the nematode populations is how much higher was the nematode population in impacted fields? I'm not sure if you have a clear picture on that, Michelle.
I don't, and I don't, Mario Tenuta might, but I don't think it was that clear. Like there were sky high numbers according to what he said in some fields, but I don't think it was as clear cut as all impacted fields had super high nematodes and all healthy fields did not. I think it was not that clear. And he didn't feel that the symptoms we're seeing are what you typically see from nematode infection. But it would be best to ask him to get the best analysis of that.
For sure, and we can do a little bit of follow-up with that specific question with Mario. So we're still, I think, learning quite a bit on the nematode front and how they may be connected or layered in, or maybe not. Yeah. Switching gears at least for a second to sort of fungicide sensitivity, but that, you know, group 11 was brought up in a couple different ways, obviously in the Anthracnose presentation, as well as Melanie mentioned it too, just Ascochyta group 11 and sensitivity in chickpea. So what does that, you know, what's on the radar, I guess, for group 7, maybe specifically through the chickpea lens? There's going to be some screening with Anthracnose and Lentil, but is the same steps being taken through Ascochyta and chickpea?
I don't have any plans to work on it. It certainly could be an issue, but it's not not something I'm looking into at the moment.
Melanie, from your experience, is there any indication or the group 7s are still pretty widely used in that fungicide rotation in your chickpea practices?
Yeah, just because we really don't have any choices, right? So I do think it would be smart to look at pushing some funding through to screening for that before it's a problem, so we know. But yeah, they're still widely used in order to just allow us to rotate. So I think it would be great if we could find a way to do some screening, even just some preliminary screening to make sure, because it's really hard to tell as an agronomist in the field, you know, the way Ascochyta spreads and the lag phase for it showing up. You know, did our fungicide work? Did it not work? It's really hard to get your head around that, right? So because you can be out there spraying and 4 days later a whole bunch of disease appears. So you know, it's hard to know. So I think it'd be great to do some screening at you know, at the lab level to make sure that we are still got all of our fungicides in our basket, because it would really not be good to lose another one.
Yeah, absolutely. One question, and this one may need some more clarity, but that there was notice of headlands in higher compacted areas were worse in 2021. And I'm not sure if indicating just yield response, a crop response, or specific to the chickpea health issue or anthracnose, but maybe we'll hone in on the chickpea health issue. Has there been any, compaction or root stress factors like that seem to, maybe irritate symptoms more, Michelle?
So I'm not quite sure if I understood the question. I think it's asking, might compaction, as in like soil compaction, be a compounding factor for the chickpea health issue?
Yes, that's how I'm going to interpret it through the lens of chickpea health, but if there's any, yes, correct. Okay, chickpea health, yeah.
I think it might be, but that's kind of anecdotally why I'm saying that. It's just that some of the fields I visited in 2020, when the issue was just showing up and there was virtually no ascochyta blight in these fields, that we'd see little patches in compacted areas. And they'd seem compacted that they might be in the headlands, or they were an area where you could see equipment tracks or kind of low areas that look compacted. So yes, it might be a factor, but I don't think it's totally consistent. Because I have also heard reports that sometimes high points in the field had more of the issue and low points did not. So that doesn't seem to me like it correlates with compaction, but I think it is possible. And if we could find a reasonable way of making compacted soil perhaps indoors to replicate it, maybe that'd be something to look into.
Fair enough. Yes, bring the field inside, absolutely. I guess on the fungicide front, and this one maybe Melanie would have some expertise with it, but the question was pertaining to if there's any new fungicide actives or co-mixes coming out for chickpea ascochyta that you're aware of.
Not that I'm aware of. I think there's more people playing with different mixes on a personal basis, right? To try to figure out how to manage it better. And I think that's actually smart. If all the products are registered, maybe we should be trying some different mixes at different stages of the crop to try and, get in front of the disease and stuff too. Not that I'm aware of, but I might be the last to know sometimes too. So.
Fair enough. I think I would echo those sentiments of what we see here. I think we'll maybe leave it there just in interest of time, and I'll turn it back over to Corey if there's any parting comments before we get on to the next part of the presentations. So thank you guys very much for your time and presentations.
All right, thanks everybody for their presentations. And yeah, if you've got questions that come up later on, just put them in and maybe Sarah will follow up on those later on. I just wanted to say too, from the board's perspective, this chickpea health issue is just a real perplexing problem, and we're certainly, going to keep after it. And I know there's a bit of there's a lot of concern in that region, and a quest for answers. We'd like to have quicker answers, but just as you can see, it's just not that simple. And so we're going to keep after it and keep supplying resources to try and get to the bottom of it and get some better direction there for chickpea growers. So we're going to just stop for our break then now, 10 minutes, and we'll be back at 10:45. So just a quick break.